Hey everyone, welcome back. Today we're going to be taking a look at a follow-up topic to my previous two videos where I discussed about game development for the Mattel Aquarius computer, and in particular today I'm going to be looking at how to use variables in BASIC on the Mattel Aquarius computer. Now if you watched my two previous videos, you'll know that I'm quite excited about the prospect of game development for the Mattel Aquarius, particularly because of these modern development tools we have available to us now, which make our job a lot easier and really a lot more enjoyable. In fact, I was able to use these tools to develop my first game for the Mattel Aquarius, which is right here, which is Dungeon Quest for the Mattel Aquarius with the Micro Expander device or Aquarius MX device. And this can be played on an actual Aquarius computer with one of those expansion devices, or it can also actually be played using the Aqualite emulator, which I'm going to be using today to explore variables in BASIC. So if you're interested in playing this game, it's now available for download on my Spriteworks itch.io site, as well as you can actually download this game and play it on your Aqualite emulator if you like, by simply loading the files into the USB folder where you've installed your Aqualite emulator. And today we're going to be taking a look at variables. So if that sounds interesting to you, stick around and we'll get started right now. Alright, so here we are in the Aqualite emulator. And as you can see, it's currently operating in regular Aquarius mode. So first of all, what I want to do is change this into Micro Expander mode. And I do that simply by going up here to the Tools menu and selecting Options. And then here under the Peripherals tab, there is an option called Micro Expander. I simply turn that on by selecting that checkbox and clicking OK. And now you can see it comes up with the boot menu for the Micro Expander or Aquarius MX. So what we want to do now is take a look at how we use variables on the Mattel Aquarius and some of the quirks that we need to be aware of when using programming variables on the Aquarius. So the first thing I want to do obviously is press return on my keyboard to enter basic mode, which is in this case USB basic version 1.0 you can see. And I believe this is actually a version of extended basic, but this USB basic has some extra commands that are available to us that we'll be using today. Well, one of them we'll be using today, which is the clear screen command, which is very handy. So if I type CLS like this, it clears the screen, and that's a very handy command at our disposal. We can use that both in immediate mode, as I've just done here, or we can use that in our programs as well, in our basic programs. Alright, so let's start talking about variables on the Mattel Aquarius computer. Now, the first thing I want to talk about is the names that we're able to use for our variables. And first let's take a look at the Aquarius user manual, which has a ton of useful information, particularly if you want to learn how to program in BASIC for the Aquarius. I suggest that the user manual is the best place to start. So I'm just going to bring it up on my screen here, right here, and I'll shrink it down a bit so we can actually see it more. There we go. All right, so let's just read what it says here about variable names. I'm going to go up one screen here, there. So numeric variable names, let's start here. It says they can be any single letter, like A for example. They can be two letters, and it says if unreserved, and we'll discuss that a bit later. And here's an example, AB, so that's two letters. And here it gives an example of the word score. It says a name up to approximately 60 characters in length. I don't know why you'd want to use a variable name that contains 60 characters, but apparently you could if you wanted to. And again, it says if unreserved. But here there's a note that says Aquarius uses only the first two letters, so it would consider this example to be the label SC. So what it's saying here is that if you were to assign a variable called score, which is actually not allowed, it's an illegal name, so I'm not sure why they use this name, but anyway, I'm going to show you why this is illegal in a moment. But if you were to use a variable that contain more than 2 characters as its name, the Aquarius computer only looks at the first 2 characters. So for example, if you were allowed to use the word score as variable name, it would ignore everything after the first 2 characters, and it would just consider this variable name as SC. And then the final note it says here is it shows an example of C5, which says a combination of a letter and a number, and the letter must be the first character. So let's go ahead and try that and see what that looks like in our emulator. So here's our emulator, and the first example it said is a single letter. So we could, let's say, use the letter A, and I could say A equals 5, print 5, or print A, and then we get a value of 5. So this is just an example of using a single letter as a variable name. You could use 2 letters like, let's say SC equals 5, print SC, and then we get a value of 5. Now, it says we can also use more than 2 letters, and before I use their score example, I'm going to use a different word that's actually allowable. Let's say the word onion. Onion equals 7. Oh, onion isn't allowed either. Okay, so let's use what would be allowed. Let's say thing. Thing, is this allowed? Equals 5. That's not allowed either. So as you can see, it's not allowing me to use these variable names. So let's talk about reserved words now, since you can see it actually can be a common occurrence that we run into this when we're trying to assign variable names. So let's see why these variable names are not allowed. Onion and thing, for example. Now let's do that by taking a look at the manual again, right here, and we're going to go down to the next page where it shows us all of the reserved words right here that we're not allowed to use as any part of our variable names. And you can see here one of the words is on, and if I go back to the emulator, we can see that my onion variable name contains the letters ON, which is on, which is a reserved word. So that's why it's not allowing me to use onion as my variable name, because it contains a reserved word on. And let's go back to the manual again and see what it doesn't like about my variable name thing. So here is our list of reserved words, and is there any reserved words in the word thing that are used in here? Let's see. I don't see any reserved words that are in the word thing. I was thinking maybe in. Is in a reserved word? Let's take a look. What if I just try to use the variable name in? In equals 5. So it doesn't let me use the word in. So in must be a reserved word as well. So that's why it's not letting me use the variable name thing. So I'm just going to clear the screen again here, and I'll let's see, what word can we use? Let's say the word begin. Begin equals 5. No, it doesn't like that because of the IN. There must be some. Okay, how about number? Number equals 7. Okay, finally, it likes the variable name number. So if we use a variable name that has more than 2 characters, the computer will only look at the first 2 characters. So in this case, number equals 7, and if I print number, it gives me the value 7. But if I print just print NU, it also gives me the value of 7. And if I print NUDDD, again it gives me the value of 7 because it's only looking at those first 2 characters. So the variable names that we are allowed to use would be any combination of 2 characters that are not reserved that begins with a letter. So for example, A1 equals 6. That's allowed, and I could say print A1 6. But the 2 letters have to start with a letter. So I couldn't say, for example, 1A equals 6. Or could I? Print 1a. No, it's just printing the number 1 and the value of the variable a, which is 0 because it hasn't been assigned. So our variable names can be either 1 or 2 characters. They have to start with a letter, and they can't contain any reserved words, and they can be longer than 2 characters, but only the first 2 characters will be considered. Any characters after the first 2 will be ignored by the computer. So let's say we start this again, and we want to use a variable name of sc. So I could say sc equals 5, and then print sc equals 5. I could say scrape equals 7, scarf equals 8, sc2 equals 9. So now if I print sc2, what value is it going to give me? Well, it should give me 9, right? Because that's the last value that I assigned to a variable that starts with sc, which it does. But now what happens if I print sc? Again, we get 9. What if I print scarf? Again, we get 9 because all of these variable names begin with the first same 2 characters, sc, and all the other characters are ignored. So as long as we don't use any reserved words in our variable names, we can use more than 2 characters, but again, anything other than the first 2 characters will be ignored. Now, another thing to take note of is the fact that variable names are not case sensitive. So you could say a equals 1. Well, actually, let me clear this first. I'll just type new. So now we know there are no variables assigned in our computer. And let's say we assign a variable a equals 1, lowercase a, and capital A equals 2. And if I say print a lowercase a, it should give us the value of 2 because that's the last value we assigned to either lower or uppercase a, because the case or capitalization is not considered. And it does give us a value of 2 because the computer does not consider the case in our variable names. It's not case sensitive. Now, one thing to be aware of is that in my development environment, which you might remember from my last video if you watched it, I shared my development environment that I use for making games and my workflow that I use. And in my particular development environment, I'm using the Visual Studio Code editor combined with the text to BAS tool. So the Visual Studio Code editor creates a text file, and then my text to BAS tool that I use converts that text file into a basic program. And why am I telling you this? Well, I'm telling you this because even though the Aquarius computer doesn't care about capitalization or case in variable names, my development tools do. So the Visual Studio Code editor combined with the text to BAS conversion tool, I think it's probably the text to BAS tool that is probably case sensitive. So when I'm creating my program, I use only capital letters because lowercase letters don't work when I'm converting my text file into a basic program. So when I'm doing my development, I only use uppercase letters in my variable names. Okay, so what do we want to talk about next in terms of variables for the Mattel Aquarius? Well, let's talk about how we can clear the variables. So here we've assigned a value to the variable a. And if I clear the screen by typing CLS, and I say print a, and again, it can be upper or lowercase, so I'm just going to use lowercase. Print a, I have a value of 2. If I want to clear the variables in the computer, I can simply type the word clear, like that. And now the variables should be cleared. So if I again print a, we get a value of 0 because that clear command clears all of the variables in the computer. Now, one thing to be aware of when using the clear command is when you're trying to use it after a go sub command, because it also erases the return line number where the go sub should return to after it's been executed. So let's start again here. I'm going to just type new and then clear screen, and we'll start fresh. And let's enter a program now. Let's say I'll enter line 10, go sub 1000, and then 1000, I'll say rem, so it doesn't do anything, and then line 2000, return. But then once it returns, I don't want it to loop endlessly, so I'll just put in a stop statement here at line 999, stop, just like that. Now I'll clear the screen, list my program, and here is our program. Line 10, go subs, line 1000. Line 1000 is just a rem statement, it does nothing. And then line 2000 returns, and it comes back up here to this stop statement. So when I run this program, it should just stop at line 999, which it does. Now, to demonstrate what I was just mentioning about the clear statement, if I, let's say, replace this rem statement at line 1000 with a clear command like that, and again I'll clear my screen, list my program. So this is our new program. It has a go sub command. It go subs line 1000, which is a clear command which wipes out all the variables, and then we have a return command after it. Well, after this clear command gets executed, the return command no longer knows how to return back to where it was called from. So this program should no longer work. So let's give it a try. And there we go. We get an RG error, which is a return without go sub error in line 2000. Because of this clear command, it's erased the line number where the return command is supposed to return back to. So this is one thing to be aware of when you're trying to use the clear command. If you ever want to clear the variables from within your program, then just be careful when you're using it after a go sub command, because the go sub command will no longer work because the return command won't be able to return back to where it came from. So that's one thing to be aware of. All right, so the next thing to be aware of is that the next thing we should talk about is arrays. So you're probably already familiar with both numeric variable arrays and string variable arrays. And if you're not familiar with arrays, you could go back and watch one of my previous videos where I discussed all about arrays, and I actually used them to create a maze, which rhymes. So although I'm sure you're probably already familiar with arrays. So an array is a variable that has more than one element and possibly even more than one dimension. So let me start over again here by typing new and clear screen. And an array on the Aquarius computer apparently can have up to about 400 some odd elements. So that's one thing to be aware of. And another thing to take note of is the fact that arrays in the Aquarius computer, they actually start at element 0, not element number 1. So for example, on a Sinclair Spectrum computer, arrays on a Sinclair Spectrum computer start at array element number 1. So for example, on a Sinclair Spectrum, there is no element number 0. And what do I mean by this? So let's assign a value to a numeric array now. So let's say I type A1 equals 5. Can't get my brackets right. A1 equals 5. Okay, so now we would expect this A array, element number 1 of the A array, to have a value of 5. And we can test that. I can simply print it. Print A1, and we get our value of 5. But A1 is not actually the lowest element number in the A array. There is actually an element number 0, which is a 0. So all arrays on the Mattel Aquarius computer start at number 0. So and I can assign a value to it. I could say A0 equals 5. And then I could print that, print A0, and I get a value of 5. So when we dimension an array, which you may be familiar with dimensioning an array, which is simply reserving space for that array in memory. Let's say I dimension an array B, let's say for example. So I'll say dim B, and then I'll give it maybe 12 elements, like that. So now you might expect the B numeric array to contain 12 elements ranging from B1 to B12, but actually it contains 13 elements. Even though we dimensioned it using a value of 12, that is not actually representing the number of elements that this array contains, but rather it's representing the highest number of the elements it contains. So the highest element number in this B array is now 12, but it also has an element number 0. So this B array contains actually 13 elements, not 12, because it ranges from B0 to B12. And again, I could assign a value to B0 if I want. B0 equals 45, print B0, and there we get our 45 back. So that's one thing to be aware of, is that all arrays on the Mattel Aquarius computer begin with element number 0. So what else do we need to be aware of with arrays? Well, actually there are a lot of things we need to be aware of when it comes to arrays on the Mattel Aquarius computer. And one thing that's interesting is that arrays that have a highest element number of 10 or below don't need to be dimensioned at all. So let's say I'll start this program over again. I'll type new CLS, and so now there are no variables in this emulator. And let's say I want to assign a value to an array that has not been dimensioned. So now nothing has been dimensioned yet. And let's say I use an array called X. So let's say I say X5, keep getting my brackets backwards, X5 equals 47. And it allows us to do that even though this X array has not been dimensioned. It still allows us to assign a value to an element within that array because the element number that we're using is below element number 11. So we can assign values to arrays that haven't been dimensioned as long as we're using elements number 0 through 10. And in this case, we're using element number 5. Now, if we did want to use an element number that's higher than 10, then we do have to dimension it. However, one other thing we need to be aware of is that we can't dimension an array that already has a value assigned to one of the elements. So let's say now I wanted to dimension this X array. I could type dim X, and maybe I want to give it 15 elements. Like this. It doesn't let me do that because the X array has already been used since I assigned a value already to element number 5 up here. So if I type clear now, and that wipes out all the variables of the computer, I should be able to dimension this X array now. So I can type again dim X 15, and now it works. And I could assign a value X, let's say 15 equals 7, print X 15, and we get our value of 7. So if an array has elements ranging from 0 to 10 or below, then we don't need to dimension it at all. But if we want to have an array that has elements above 10, so elements 11 and above, then we do need to dimension it. Okay, so what else should we discuss about arrays? One thing that we need to be aware of is this value that we use in our dim statement here. So this dim x15, we're not actually assigning 15 elements to this array, but rather we're specifying the highest element number, which in this case would be element number 15. So our X array would actually contain 16 elements ranging from 0 through 15, which is a total of 16 different elements. So that's one thing to be aware of, is that this number that we use in our dimension statement is not specifying the total number of elements in the array, but rather it's specifying the highest number for the elements in the array. And then the number of elements in the array is always one higher than this value that we put in our dim statement, which makes sense. Okay, so now what we want to discuss is we're going to continue talking about dimensioning an array. And in this case, you can see I've dimensioned the X array with 15 elements, and I've assigned a value to the 15th element. And so I'm just going to clear the screen here. I'm not clearing the variables, I'm just simply clearing the screen. And so my X15 element should still have a value. So if I print X15, I get my value of 7 back. But let's say I decide I actually need more than 15 elements in this X array. Well, I could try to redimension it by typing dim X. Maybe I need elements going up to element number 20, for example. Well, the computer won't let me do that because we've already dimensioned this array previously. So if we have an array that's already been dimensioned, the computer won't let us redimension it with a different value. Once it's already been dimensioned, the only thing we can do is to erase the original dimension by using the clear statement or typing new, or obviously if it's in a program that we're dimensioning it, we would change the value of our original dimension statement. So we can't redimension an existing array once it's been assigned. And as we saw previously, we also can't dimension an array once we've assigned a value to one of the elements. So those are two things that we need to be aware of as well. All right, now let's start again by typing new, clear screen, and we're going to discuss an interesting quirk about the Mattel Aquarius computer, which I don't know if this feature exists on other personal computers or not. Maybe it does, I'm not sure, but one interesting aspect of the Aquarius is that it has something called a string buffer. So you may be familiar with string variables. For example, I could assign a string variable a string equals hello, print a string, and I get this alphanumeric value of hello that I've assigned to this string variable called a string. Well, this computer has something called a string buffer, which determines how many characters are available to be assigned to string variables in the computer. So what I'm going to do is actually type new again to clear out everything and type clear screen. And the way we can find out how large the string buffer is in the computer is there's two ways we can do it. And they both use the free keyword or free command. So here I'm going to just type print free and then open a bracket. And now there's two ways we can do it. We can do it this way, which is typing a quotation mark with a letter inside of it, and you could use any letter, and then close the bracket and press return, and we get a value of 50. So that means this computer is currently set up to allow us to store 50 total characters in string variables. So if I were to assign a variable now, let's say a string again equals hello. So the word hello contains 5 characters, and that should use up 5 characters in our string buffer. And if I type print free a again, like this, we can see the value of the string buffer now is 45 because we've used up 5 characters from that original 50 value up here, because our hello word contains 5 letters, and there are now only 45 available spaces left in our string buffer. So what happens if we want to assign more than 50 characters to string variables in our program? Well, we can easily change the number of available spaces in our string buffer by using the clear command again. But this time, when we type the word clear, like this, as we just saw, if we press return right now, it's going to simply clear out all the variable values in our computer. But if we put a number after this word clear, like let's say 76, for example, and we press return, now our string buffer should have a length of 76 characters. And we can check that by typing print free. And this time, instead of using a letter contained inside of quotations, let's use the other method, which is by typing a letter followed by the $sign, like that. And then we close our bracket. And this will again tell us the size of our string buffer, which now has been changed to 76 because we just reassigned it a length of 76. And if I assign a string variable, let's say b string equals apple, maybe I'll use a different word, like b string equals country. So that's 7 characters. And now let's see what happens to the length of our string buffer now that I've assigned this 7 character word. So again, I'll type print free a string, or whatever letter string you want. We could type maybe whatever G string. G string. Okay, maybe we won't use G string. We'll use Z string or Z string. No, I'll use okay, W string. How about that? So we use W string, print free W string, and now we can see 69. Okay, so the value of our available string buffer has dropped from 76 down to 69, which is 7 characters fewer because we've used up 7 characters in this B string, which has a value of country, which contains 7 characters. So the whole point of this is to be aware of that there is a limitation of how many characters you can assign to strings in your entire program. This isn't the length of each individual string. This is the total combined length of all the strings combined in your program as a total. So all of the string variables can only have a maximum number of characters equal to or less than whatever the length of the string buffer is. And again, you can find out what the length of the string buffer is by using this free command, either with a character followed by a $sign or a character contained within quotes. Okay, so that is very important to be aware of, because once you start running out of string variable spaces in the string buffer, then the computer is not going to work as you expect it to work. Okay, so that is very useful to know. Let's move on to our next topic, which is looking at the available free memory in the computer. So let me just clear this now. I'll type new CLS. And so we took a look at the string buffer and how to find out how many characters are available in our string buffer. But now let's take a look at how much free memory there is in our computer available for us to type our basic program. And again, we do this by using the free keyword. So if I type print free, and then what we need to type after this is a bracket, and then pretty much any character. Like you could use the character, let's say D, and then press enter, and it tells us the amount of available RAM memory in our computer available for typing our basic program, which is in this case 31,064 bytes. Now, what I like to do is, when I'm using this emulator, is I like to use the 8 character, because the number 8 is on the same key as the left bracket, so I can easily type print free open bracket 8 close bracket, and that gives me my result there as well. Now here's an interesting thing I want to discuss, which was something I ran into when I was creating my Dungeon Quest program that I showed you at the beginning of this video. When I was creating this game actually, even though it's designed for the micro expander device or the Aqualite emulator using micro expander mode enabled, which gives us 32K of RAM to work with, I found that my program was acting strangely, because I was actually reaching the limit of that 32K memory in my program. which I was able to fix that problem because my program was designed very inefficiently at that time. So I went through the whole thing and cleaned up a lot of space. But one thing I realized was that the way my program was working is it was assigning variables on the fly as the program was running. So let's say, for example, I'll just start again here. New, clear screen. So now let's say we want to check the amount of free memory in our computer as variables are getting assigned. So let's create a program here. Let's say line number 10. Let's say line number 100, actually. 100, print free 8. That will give us the number of free bytes available on our computer, our free RAM memory available. And then line 110, I'll assign a variable, a equals 1. Line 120, print free 8. Line 130, and I'll assign another variable, b equals 2. Line 140, print free 8. Line 150, c equals 3. And it doesn't matter what values I assign to these variables. They can be any value you want. And then line 160, print free 8. And that 8 can be any character, like I said. So this program will show us the amount of free memory available in our computer as these variables get assigned one by one. So let's go ahead and run this program. And you can see here that the value of the available free memory drops by 6 bytes every time a new variable gets assigned. So each of these numeric variables takes up 6 bytes of memory in the computer. So our available memory drops from 30,996 to 30,990, then 30,984, and then 978. So every time these variables get assigned, obviously they take up memory in the computer. And I found that that was causing problems with my game because the computer would assign variables as it runs, which would take up more and more space in the computer. So what I decided to do was actually assign all the variables up front in a subroutine. So, and we can try this in this program as well. So I'll just clear the screen and list the program here. So here's our program. Now what if we wanted to assign initial values to all these variables up front and reserve space in the memory for all of our variables that we're using in our program up front? So let's do that here at, let's say, line 1000. I could say a equals 0, and line 1010, b equals 0, line 1020. And of course this is a very inefficient way of programming, but it it demonstrates our point that we're trying to get across here anyway. So c equals 0. So now what this does is this is going to reserve space for all of these variables by assigning them default values, in this case 0. And since this is going to be a subroutine, I want to put a return statement at the end, so I'll put 2000 return like that. And then at the beginning of the program, I'll put a go sub instruction to call this subroutine. And I'll put that maybe at line 50, go sub 1000. And then since I don't want my program to run into this subroutine, I'm going to put a stop statement at line, let's say 999. 999 stop, like that. Oops, stupid. 999 stop. And then I'll clear the screen and list the program. So here is our program now. Line 50 has a go sub command which will call this subroutine at line 1000, where it's going to assign initial values of 0 in this case to each of these 3 variables, and that will reserve space in memory for these 3 variables. And then it will return back to our program here, which will print the amount of free memory on the screen as new values are being assigned to these same variables. So this is what would happen in a program as it's running. You could have a variable initialization subroutine to assign initial values to the variables, and then as the program is running, it will assign new values to those variables But since these initial values have already been assigned up front, then you can easily see how much memory you have available to work with once these values have been assigned. So now if I run this program, we can see that the number of free available bytes in memory doesn't change as these new values get assigned to these variables from within the program, because they've all been pre-initialized up front in this subroutine. So this is a handy technique to use if you think you might be running out of memory in your program and you're not sure how much memory your variables are using. An easy way to get around this is to simply assign values to all of the variables up front in a subroutine like this. And now, if I list this program again, we could also reserve space for arrays in the same way. So let's say we have a numeric array that we want to assign, that we want to reserve space for, but we might not want to necessarily assign values to all the elements in the array. We could assign values to every element in our variable arrays in our variable initialization subroutine if we wanted, but it's not really necessary because we can simply dimension those arrays and that will reserve the space for them as well. So let's try that in line 1030 here. I'm going to dimension an array called X, and I'll give it, let's say, 50 elements. So now, if we clear the screen and list our program, we can see our variable initialization subroutine here is going to assign values of 0 to these three numeric arrays. Then it's going to reserve space in memory for this X, or sorry, for these three variables A, B, and C. Those are not arrays, they're just simple numeric variables. They're being assigned values of 0, these initial values. And then this line 1030 is going to dimension this X array, and this numeric array is going to reserve 50 spaces in the array for 50 elements. So by doing this up front, we can reserve space in the computer for all of the variables that we use in our program, and we don't have to worry about running out of memory unexpectedly as our program runs and assigns new values to these variables as the program is running. So if we run this program now, it will show us the new value for available memory with this new X array having been assigned as well. And there you can see we now have available memory of 30708 after both this X array has been assigned as well as these three numeric variables. So that's a handy kind of trick to use to try and avoid running out of memory in your program. Okay, so now the next point I want to let you know is that when you're dimensioning an array, it's a good idea to not dimension any more elements than you actually need. So let's say in our X array here, you can see we've assigned a value of 50 to this X array, which is going to reserve, actually, as we now know, it will reserve 51 elements ranging from X0 to X50. So if we're not actually going to be using all 51 of these elements, let's say we finish programming our game and we determine that our X array only requires maybe 30 elements, then we should change this value to 30 so that we don't reserve any more space than we absolutely need, and then we again will hopefully avoid running out of memory in our program. So I'm going to clear this again by typing new and clear screen, and then I forget if I mentioned this earlier on in the video, but this is the last point I have to bring up, and if I did mention it, then just bear with me, I'll mention it again. But that is, if an array has fewer than 11 elements, it doesn't need to be dimensioned. So I think I might have covered this already, but as I may or may not have mentioned previously, if we have an array that has elements 0 through 10, we don't have to dimension it, so I can simply assign a value to, let's say, A10 equals 7, for example, And the computer lets me do that even without dimensioning this array. However, if we want to have an array that has more than 11 elements, or it has element number 11 and above, if I try to assign a value to element A11, for example, A11 equals 9, it doesn't let me do that because that's too many elements for one array without dimensioning it. So in this case, I would need to dimension it, and so I'll type clear to erase the variables, and this time I'm going to actually dimension this A array, dim A, let's say 11. Maybe I want 11 elements total, or 11 plus 0, so elements 0 through 11, which will give us a total of 12 elements to work with. And then now I should be able to assign a value to element number 11. So I could say A11 equals 25, and now it lets me assign it, and I can print that. Print A11, just like that, and we get our 25 value being returned. So there we go. We have some tips and quirks, and I'm sure there are other things to discover about variables on the Mattel Aquarius when programming in BASIC, but these are some of the issues I ran across in programming my game, and hopefully this information will be of some value to you if you try and program games and programs on your Mattel Aquarius computer or in the Aqualite emulator, as I'm doing here. Alright, so there we have some tips and tricks for using variables on the Mattel Aquarius computer when programming in BASIC, and hopefully they're of use to you when programming your own programs and games. And again, if you're interested in checking out the game that I made, Dungeon Quest for the Mattel Aquarius with a micro expander, or Aquarius MX, or Aqualite emulator, however you want to play it, it's available now for download on my itch.io site, which is spriteworks.itch.io. And again, thanks to my subscribers on the Patreon channel. And if you're interested in checking out my Patreon site, you can sign up there to become a subscriber and help support more videos and more projects and more games. So as always, thanks for watching, and we'll see you next time.